In this video, we will learn about the basics of numerical solution of equation, and then our focus will be on finding the location of roots by means of a sketch. Now, first of all, what is this topic all about? If we have an equation like this, which is a linear equation, we know how to solve it. If we have an equation x square minus 5x plus 6 equals to 0, this is a quadratic equation and we also know how to solve it. For that matter, if we have sine 2x equals to 0.5 and x lies between 0 and 360 degrees, this is a trig equation. We can also solve this. If we have something like e raised to power of 2x plus e raised to power of x equals to 0, we can solve this exponential equation also. But what if we have an equation something like x sine x plus 1 equals to 0, x e to x plus 5x equals to 0? These equations cannot be solved using the normal means. So therefore, we need to study this particular topic that is called numerical solution of equation. What this chapter is all about, that such equations can be solved by the process of a formula, which is known as the iterative formula, also known as iteration. That is of this format, xn plus 1 is a function of xn, and that will come at the end of this topic. How to reach this particular stage? Sometimes we have to prove something by the concept of circular measure. Sometimes we have to prove something by differentiation, sometimes by integration. Sometimes we have to draw sketches and we have to prove that this equation has maybe one real root or maybe two real roots and so on. Sometimes we have to apply a change of sign method to show that the root lies between two values. So now everything that we talked about over here is basically falls under the category of this chapter that is known as numerical solution of equations. So let's first get started with the concept of drawing a sketch. For example, if I have this quadratic equation y equals to x square minus 2x, and if I ask you to find the solution of the equation y is equals to 0, what you will do is to solve it algebraically. Whenever there is a possibility of taking common, we will take common. Two terms, two brackets are multiplying to give us 0. That means either one of them is 0. So therefore x is 0. X minus 2 is 0. Therefore x is equals to 2. Now this working is based on algebra and it was a simple working to do. What if I ask you to plot the graph y is equals to x square minus 2x? We can apply the knowledge of quadratics. We can take x common out, x minus 2. And we know that this is the factorized form of the quadratic equation. The coefficient of x square is positive. So let me write it at this corner. So coefficient of x square is positive. That means that's the shape of the graph. A graph in which there is a turning point, which is a minimum point, also known as a minima. Similarly, if I talk about the roots of the equation, that means the x-intercepts. What we do is that we make y equals to 0, x bracket x minus 2 equals to 0, therefore x is 0, therefore x minus 2 equals to 0. In other words, x is equals to 2. So we get two roots, 0 and 2. We know the shape of the graph. So therefore, what we can do is that we can just draw a simple plot over here. And the graph goes something like this. It's just a rough diagram. This is the x-axis. This is the y-axis. This is the point 0. That's one root and this is the point 2. Now, that was a simple example. What I wanted to emphasize is that we have one equation, y is equals to x square minus 2x. Whether I solve it algebraically, whether I solve it based upon the sketch, I get the exact same answer, which is x is equals to 0, x is equals to 2. These are known as x-intercepts. These are known as solution of equation. These are also known as roots of equation. Now, let's go one more step further. And let's see if we break this particular equation up into two pieces. X square minus 2x equals to 0. We are looking for the roots. Let's write x square on the left, 2x on the right. Let's draw the graph of y is equals to x square. Let's draw the graph of y is equals to 2x and let's see what happens. So if I draw the graph of y is equals to 2x, it's a straight line, and that's how we draw it, a straight line in which the gradient is positive and the y-intercept is 0. Now let's draw the quadratic graph y equals to x square. So somewhat like this is the quadratic graph. Now we can see that there are 2 points of intersection between the two lines. If this was an exact graph, this answer comes out to be 2, this answer comes out to be 0. So what have we learned from this simple example? We have learned that if we have the graph of y is equals to x square minus 2x, the first option is to solve it using algebra, and we got two answers, x is 0, x is 2. The second option is if I am able to sketch this graph, which I can, because this is a quadratic graph and the factorized form is x minus 2, the roots of this equation, also known as the x-intercepts, these answers came out to be exactly the same thing, which is x is 0, x is 2. Now comes the third option. That is, we have this equation x square minus 2x equals to 0. We are looking for the roots of this original equation. So one option is break it up into two parts, x square equals to 2x. Draw the simple quadratic y is equals to x square. Draw the simple straight line y is equals to 2x. And the points of intersection of these two graphs is the same thing as solution of the original equation. That means the original equation solution, that is known as roots of equation, is the same thing as if I draw two separate graphs on the same grid, let them intersect, so these two answers will exactly be the same, which is x is 0, x is 2. Now we will use this knowledge to locate the roots based upon a sketch. So an equation will be given. That particular equation will be broken up into two parts. We will sketch each part separately, and the point of intersection, it could be the point, it could be the points of intersection of these graphs, will tell us the number of roots of the original equation. So in the videos that follow, we will be doing more example on this.